we're looking from page 63 in the textbook, and it's very important that we understand how to put things into Venn diagrams. And it starts simple, and then it starts getting a bit more complicated, and we have to use algebra to find unknown values and things like that. So we're just going to start with the basics of being able to put numbers in a Venn diagram. Okay. So should we have a look at example 5 and go through it? Or would you like to read it and tell me whether you need to or not? Would you like me to go through it?
Yes, please.
Okay. So, if we're having a look at example 5, it says, if U, what's U by the way?
Universal.
Universal set. Okay. So it's telling us in example 5 that the set U are the numbers 1, 2, 3, 4, 5, 6, and 7. Okay. It is then telling you a set E is 2, 3, 5, and 7. What can you say about E and U, a relationship between the two, by the way? Yeah.
They both have 2, 3, 5, 7.
Okay, so they both have 2, 3, and 5, 7. Can we say that E is a what? Have we done that yet? Subset. So we can say E is a subset of U, which is good because we don't want anything that's not in the universal set. So basically everything now should be a subset. Do we know the notation for subset? So E with this symbol, U. So E is a subset of U. All right.
It means subset?
Yeah, so that symbol there means subset.
So if we were to change U to A and E to B, you could say that B is a subset of A?
Exactly. Yeah. So this example says list the elements. You all know what we mean by elements, don't you?
Yes.
Things that are in the set. List the elements of E dash. So E dash. Well, do you know what that symbol means? Anyone? So that little dash there means. Pardon?
Element something?
No, E doesn't, actually this E doesn't stand for elements actually. They've not used nice letters in that way. Elements is given this symbol, a curly E. I don't know if you've seen that one.
Is it outside?
But this one, yeah, I think you get it, is actually in proper language the complement of E. And another way of saying it is not in E. Okay. So we've got to list the elements that are not in E, basically. That's what that little dash means. So maybe we should just highlight that's what that little dash means. The complement of E.
Oh.
Is that too dark? Nice colour. Alright. So any ideas what we would write? So we've got the curly brackets because we're writing a set, listing the elements of. So what would I write? 0, 1, 6. Is that it? Yeah, 4 first. We'll go 4. 6. Anything else? No. Look at that bracket. That's cool. Completely. just to check, what we can do is we can identify that 2, 3, 5 and 7 are in E, so it's the ones that are left that we should have written 0, 1, 4, 6, which it is, so we're fine. We're good. Okay. Okay, let's, it now says, illustrate E and the complement of E on a Venn diagram. Okay, so you'll be expected to be able to draw a Venn diagram of this. So, the first bit of a Venn diagram, hopefully we know now, is the rectangle. We've got to have a rectangle, haven't we? So, Venn diagram has to have a rectangle. Doesn't need to be very big because that's U. And inside U we only have one subset given to us, which is E. So I can just draw my circle, and that is represented E. So to show it in a Venn diagram, we just put the values.
So when you only have one
subset, yeah, one set. Yeah, exactly. So then, not in E, the ones not in E, go outside the circle. So 0, 1, 4, 6. Doesn't really matter where, as long as they're outside the circle. And the ones that are left, that we've decided are in E, 2, 3, 5, 7, have to go inside the circle. And then we've got to answer the questions. Okay, so just to highlight, so E, what's in the circle, should be what was given to us as set E to start with. Okay? So that's what we've got there. So E is just my label. And then the ones that are not in E should be on the outside of the circle. Okay, so all of those should be there. Okay, so we have these questions to answer. We have NE complement of E, NU. Now N means what is the number of elements in. Okay, so NE means how many elements are there. So there are 4. Okay. Some people make the mistake of listing the numbers, but we actually want to know how many numbers. Some people make the mistake of adding the numbers up, but we don't want to know. Each number is a separate element. That's all. So what about N complement of E?
4.
4 again. NU? 8. Okay.
And universal is all of them.
Which bit are you confused with?
Because it's 4. Wait, and rhyme you?
Got it?
U is the one with you.
U is everything in the rectangle. So U, this number here, so this number here for NU should be the number of numbers we were given originally. So 1, 2, 3, 4, 5, 6, 7, 8.
And the E of complement is the one on the blue.
The outside, yeah. So, not E, there are 4 numbers, and number in E, there are also 4.
Yeah, maybe her.
Okay. So there's a bit of chat going on. Let's move on to the next one. Okay, we're ready. Have a look at example 7 over the page. Okay. Now, obviously, the answer's there. All right. But what I would like you to do is write out that question. See whether you can do the Venn diagram and come up with the same answer. We'll give you 5 minutes, and if you're really struggling, we'll go through it together. Example 7, page 64. Obviously, in the white box is the answer. Try and ignore the white box. Okay. So do the bit that's kind of in brown first, and then see whether you get the same thing. With your help. So this question. So first of all, I've written out. I've been giving you in what type of notation? What's this notation called?
Something that's
Correct notation.
Yes.
So it's begins with I.
No.
Yeah.
Intersection.
No.
No.
Interval. There you go. Interval notation. Okay. It's interval because it's an interval of 0 to. You know, if you go to a play or a performance, what's the interval? Well, it might be the middle, it might be a break, yeah? So you're at the interval. The interval in a show is the end of the first section. So what we have is we have the beginning and end of the interval. That's what we've been given. That's why it's called interval notation. So we need to really know, and I don't know why that just changed to red. We need to know, list the elements. So what are the elements? 0. So this here means what again? X is an element of integers. Okay? And between 0 and 12, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Now you might get to a point where you say you don't need to write it out. You go straight into the flow. Okay. Now we are told though that we have 2 sets, so that would suggest we're going to have 2 circles within our rectangle. So A is 2, 3, 5, 7, 11. Okay. And B is, they're getting worse, 1, 3, 6, 7, 8. It's a good job you don't lose marks from not having a good bracket. Okay. So, what we need to do is show that. Now, do you notice something before we draw the Venn diagram? What do you notice about the sets A and B? Okay.
There are numbers missing from the.
Okay, so some of them are missing. Which ones? Do you know which ones?
9. 0.
9's not in either. 0.
10, 4. 4. Wow. They both have 3.
Okay, so that's the next question. Is there anything else? Yeah. Lucy?
I'm going to say that numbers are the same.
They have numbers that are the same, which would be
3,
3 and 7. Is that it? Okay. So when we see that, we know we've got a Venn diagram. Now our Venn diagram is always going to have a rectangle, but when we've got 2 sets and the sets we can see have things in common, what does that mean about the circles? They have to overlap. Now, if there was nothing in common, would the circles overlap? No. Would it matter if you drew it so that they did? What would happen to that section in the middle? It would have nothing in it. Now, so there's two things just to notice about that. A, it wouldn't affect your answers for everything else, but it would suggest to an examiner that maybe you don't really understand properly. So if you had to draw a Venn diagram and you overlapped circles where there was no overlap, it would make them think twice about whether they have to give you all the marks just for the Venn diagram. Okay, so just have a look. If it doesn't overlap, don't overlap. The other thing is to consider whether there's anything that is outside of the other circle. So maybe it's a subset. So just have a look back over the page to the little pink one under the one we did. Turn back over the page. You'll notice that A and B is actually completely in A. Okay? So that would be something to notice. Right, back to this one then. So we've got to put the things in. So A and B. We've identified that 3 and 7 are in both. So where do they go? In the middle. So 3 and 7 should go there. Now, my tip, cross them out. And we know we've used them. I could cross out 3 and 7 in there as well. Right? And then in A still needs to be 2, 5 and 11. So we've got 2, 5, 11. So I'm going to cross them out there as well. Just little things that if you have you're doing an exam, you can make sure that you're not making the little mistakes. That attention to detail. And then this one we've got 1, 6 and 8. So cross that. So we've got 1, 6 and 8. Now hopefully we're left with 0, 4, 9, 10. And where do they go?
On the outside.
0, 4, 9, 10, 12. Good.
They put them all around the circle?
Yeah. Just to use the space, that's all. It doesn't matter. I can put them anywhere I like. I just write them there just for ease of doing it. As long as they're there. Yeah.
What if there's a number in common between A and B but not U?
Well, if it's in A and B, it has to be in U because U is the universal set. Okay, so if it's in A and B, it will be in U. You won't ever get a situation where it's not. Okay. But what you might do, actually, potentially, is they could say, does number 13 belong in the Venn diagram? And you would say no, and they'd ask for a reason why, and you would say, because it's not a universal set, falls outside. Okay.
And would you put that, and then if they ask you, where would it go, you'll put that.
Oh, you wouldn't be able to put it anywhere. Because we don't work outside of the rectangle. That's what the rectangle's for. Right? You know, it's, you know, like we talk about the class, if there was someone that was not in our class, am I giving them homework?
Yes. No.
No, it's not. Yeah, am I giving them a grade? No, I'm not. They're not in our universal set. They're not in our reckoning. We don't think about them as someone else's problem. Okay. Right. How do you feel about that? Is that all right?
Yeah.
Now, if I said to you, just extending this then, just to ask you a few questions that's not there, what if I said to you now to answer these? So, N, A, N, complement of B, N, like that. Okay. And then a tough one for those that feel like they want the challenge. Okay, have a go. If you can't get it, we'll go through them together in a sec, but this is the point we need to get to eventually. Okay, let's go through this one then. So it looks like I've introduced some new symbols to you. Right. Now, NA, we know the N stands for number of elements in. So the number of elements in A is 1, 2, 3, 4, 5. So we should have 5.
I told you. I forgot.
Just because they're also in B does not stop them being in A, if anyone thought about that. Number of elements not in B. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Okay. Now, this symbol here means union, which means all. So how many in A or B? So basically the union would be when you have both circles and you consider everything in both circles. So we'll get to shading circles in what's coming. So that would mean we have 1, 2, 3, 4, 5, 6, 7, 8. There are 8 elements in that region.
I agree.
You agree?
I also agree.
This symbol here means intersection, and it's the word and. So we say what is in A and in B. So that is, if we have the circles, just that region in the middle. Just there. Okay. So we would have 2 in this case. So this one, again, the number of elements in A intersection not B. So this is where the difficulty level moves up a little bit, but you just have to think logically, step by step. So what we're saying is, how many elements are in A and not in B? 3. Which part of the diagram would that be? Just those 3. Okay. So if I were to draw it, and why is this changed again?
Why didn't you just ask someone else? They want to be difficult.
Okay. How do you feel about those ones? Any questions on any of that? Okay. Can I ask you then to do now? So I know we've only got 5 minutes, but you can finish this one off if it's not done. Can I get you to look at question 4 from exercise 2D? So that's still page 64. Okay. You've got A, B, or C. You pick one of those to do. A, B, or C. You decide, but do one of them. Okay.